Samuel Garrett was 25 years old when he returned to Kansas Territory in October 1865, carrying a war injury that would never fully heal and engineering knowledge that would save his life. He'd served 3 years with the Union Army Corps of Engineers, building fortifications, bridges, and winter quarters, had seen men freeze to death in inadequate shelters, had learned that proper construction meant the difference between survival and death. His family's homestead claim 160 acres near Lawrence, Kansas was waiting for him. His parents had both died from typhoid in 1863 while he was serving in Tennessee. The land was legally his through inheritance, but it was raw prairie with no structures, no improvements, just grassland and possibility. He arrived with $60 in mustering out pay, a service revolver, and knowledge about thermal engineering that most frontier settlers didn't possess. The October deadline for establishing residency was approaching. He needed shelter built before Kansas winter arrived. Had maybe 6 weeks to create something livable. The conventional choice was obvious: build a small frame cabin using purchased lumber, but $60 wouldn't cover lumber costs plus other necessities. A typical 12 by 14 cabin required, perhaps, 800 board feet of lumber at $4 per $132 just for wall boards, plus more for roof, floor, door, window. The mathematics didn't work. Samuel chose the dugout design that frontier settlers used when they couldn't afford lumber, but he wouldn't build a conventional dugout, a simple hole with sod roof that stayed damp and cold. He'd build something based on military fortification principles he'd learned constructing winter quarters for troops. The innovation was double-wall construction combined with internal thermal mass principles he'd seen used in powder magazines that needed stable temperature. A conventional dugout had earthen walls that stayed cold and damp. His design would have 2 walls with an air gap between them and a stone interior lining that would store heat. He selected his site carefully using knowledge from military engineering. South-facing hillside for maximum winter sun exposure, well-drained soil to prevent water accumulation, claret earth that would pack firmly and resist erosion, located water source a spring 200 yards away that would provide year-round supply. The excavation began October 15th. He marked dimensions: 16 feet long, 12 feet wide, 192 square feet of interior space. Would dig into the hillside horizontally, creating a room that was mostly underground but with the front wall exposed to south. The digging was brutal labor that tested his war-weakened body. He'd taken a mini-ball through his left shoulder at the Battle of Kennesaw Mountain in June 1864. The wound had healed but left him with perhaps 70% strength in that arm. Every spadeful of earth stressed the damaged shoulder, but he worked through the pain because failure meant death when winter arrived. Progress was measured in cubic yards. He could excavate approximately 2 cubic yards daily, working dawn to dusk, roughly 54 cubic feet. The dugout required excavating 16 feet deep into the hillside, 12 feet wide, 7 feet high. That was roughly 1,344 cubic feet, 5 days of digging if he maintained pace. He worked through October with focused intensity. The shoulder pain was constant but manageable. More difficult was the psychological challenge of working alone on empty prairie with winter approaching and no backup plan if he failed. The war had taught him that fear was useful if channeled into action rather than paralysis. By November 1st, the basic excavation was complete. He'd carved a room into the hillside 16 feet deep, 12 feet wide, 7 feet high at the front, tapering to 6 feet at the back. The space felt like a cave. Cold earth walls, damp soil, dark. Exactly what a conventional dugout would be. Then he began the modifications that would transform it into something far superior to any conventional dugout on the Kansas frontier. First, the double wall system that would prove to be the critical innovation. He cut sod blocks from the prairie surrounding his claim-thick Kansas prairie sod, with roots so densely matted they held together like bricks. The root systems of buffalo grass, bluestem, and other prairie species created a matrix so tough that settlers joked you could build houses from it. They were right. Each sod block required careful cutting. He'd use a spade to score the surface, creating rectangles roughly 18 inches long by 12 inches wide, then cut down 4 inches deep, severing the root mat, lever the block up. Each block weighed perhaps 40 pounds, mostly soil, held together by that incredible root network. He needed approximately 400 blocks to line the entire interior walls and ceiling. At 10 blocks per hour of sustained cutting and carrying, that meant 40 hours of just sod block preparation. He worked through early November cutting blocks, stacking them near the dugout entrance, organizing them by size and quality. The actual wall construction was precise engineering. He started at floor level against the earthen back wall, laid the first course of sod blocks with grass side down. The root mat would face the interior living space, the cut soil side against the earth. This first course was critical, had to be level and stable because everything above would depend on it. He positioned each block 6 inches away from the earthen wall, used small stones as spacers to maintain that consistent gap. The 6 inches was calculated based on thermal insulation principles to narrow, and convection would transfer heat across the gap to wide, and the gap became useless air volume rather than insulating dead airspace. The second course went on top of the first, offset by half a block length for stability. Classic bricklaying pattern. The sod blocks were flexible enough to compress slightly underweight, creating tight joints. As each course rose, the natural moisture in the sod blocks would help them adhere to each other. He worked course by course, maintaining the 6-inch gap religiously. The wall rose gradually, 3 feet high after 3 days, 4 feet after 5 days, 5 feet after a week. His damaged shoulder ached constantly from the repetitive lifting of 40-pound blocks. But the pain was manageable compared to what he'd endured recovering from the gunshot wound. By the time he reached 6 feet height at the front wall, matching the excavated ceiling, he'd used approximately 350 blocks and created a complete double wall system throughout the dugout. The earthen outer wall at ground temperature, the sod inner wall facing the living space. 6 inches of trapped air between them, acting as insulation. Second, the thermal mass system that would store and release heat through each daily cycle. He began gathering river stones from Wakarusa Creek, half a mile south. The creek bed was filled with smooth, rounded stones deposited by centuries of water, fluigneous and sedimentary rocks, ranging from fist-sized to 50-pound boulders. The work was brutally physical. He'd walk to the creek, carrying a canvas sack, fill it with stones until it weighed perhaps 60 pounds, carry it back to the dugout, dump the stones, return to the creek, repeat. Each round trip took roughly 45 minutes, including loading. He could make perhaps 10 trips per day. That was 600 pounds of stone per day. He needed approximately 6,000 pounds, total 3 tons. At 600 pounds daily, that meant 10 days of sustained stone gathering. The damaged shoulders screamed in protest, but he pushed through, understanding that the thermal mass was essential to the system functioning as designed. The stone placement was strategic. He positioned the largest stones 30 to 50 pounds each against the base of the sod interior wall. These would form the foundation layer, then medium stones 10 to 20 pounds in the middle sections, smaller stones 5 to 10 pounds, filling gaps and creating a relatively smooth interior surface. He didn't mortar them initially, just dry stacked them against the sod wall, creating a stone lining approximately 6 to 8 inches thick throughout the dugout. Later, he'd fill the gaps between stones with clay mud, not for structural support, but to prevent air circulation behind the stones that would reduce thermal contact with the sod wall. The physics were straightforward. Stone has specific heat of roughly 0.2 BTU per pound per degree Fahrenheit. 6,000 pounds warming by 10 degrees would store 12,000 BTU, warming by 20 degrees 24,000 BTU. That stored heat would radiate back into the room for hours after fires died, maintaining stable temperature overnight. Third, the controlled airflow system. He built a small firebox in one corner using flat stones, connected it to a chimney that exited through the sod roof. But critically, he also installed a ventilation shaft, a vertical channel running from floor level near the firebox up through the roof. This created a convection loop. Fresh air would enter through the door, flow across the floor, rise at the firebox, exit through the chimney. The constant slow air circulation would prevent dampness while maintaining oxygen levels. Military winter quarters used similar systems to prevent suffocation and mold. Fourth, the south-facing glazing. He couldn't afford glass windows, but he installed a translucent oiled cloth panel on the south-facing wall. This allowed daylight penetration, and some solar heat gain, minimal but better than complete darkness. By late November, the dugout was complete. The structure looked bizarre from outside: a south-facing door and small oiled cloth window set into a hillside, with a chimney and ventilation shaft protruding from the grass-covered roof. No visible walls above ground, just openings in a hill. Inside was equally strange. Stone-lined walls creating a curved interior. The stones mortared with clay mud. A wooden floor he'd built from salvaged cottonwood planks to keep him off the damp earth. The small firebox in the corner, the whole space feeling like a stone-lined cave that someone had attempted to make habitable. He moved in December 1st with minimal possessions: a bedroll, cooking pot, his service rifle. The $60 reduced to $23 after purchasing necessary materials. Began his first winter in the double-wall thermal mass dugout. The neighbors' reactions ranged from pity to mockery. The nearest settlement was Lawrence, 5 miles away. Word spread about the Union veteran who'd built some kind of crazy stone-lined hole in the ground instead of a proper cabin. Robert Kincaid, who owned the adjacent claim, visited in early December and couldn't hide his skepticism. "Garrett, you've built a tomb, a stone-lined cave. This won't stay warm. Everyone knows dugouts are cold and damp. And you made it worse by lining it with rocks. Rocks are cold. Why would you build a cold rock cave? The rocks store heat. The double walls provide insulation. The airflow prevents dampness. It's based on military engineering principles for winter quarters and powder magazines. It's based on wasted effort. You should have built a proper cabin. This dugout is going to be a frozen hole when real winter hits. You'll freeze or you'll abandon it and come to town begging for shelter." Samuel had learned in the war not to argue with people who'd already decided. He thanked Kincaid for his concern and watched him leave, certain he'd be proven wrong by experience. Through December, the dugout performed exactly as Samuel's engineering calculations predicted, and he began documenting the thermal behavior with the methodical precision he'd learned in military service. The double-wall construction prevented direct heat loss from interior to cold earth in ways that were measurable and consistent. A conventional dugout with single earthen wall would have interior surface temperature matching the earth maybe 45 degrees. That cold surface would constantly suck heat from the air, requiring continuous heating to maintain comfort. Samuel's design was different. The earthen outer wall stayed at ground temperature, 45 to 50 degrees, as predicted, but the sod inner wall temperature was determined by the interior air temperature, not the earth. When he maintained 60-degree interior air, the sod wall surface would stabilize around 58 degrees. The 6-inch air gap prevented the earthen wall's 45 degrees from directly cooling the sod wall. The result was dramatic reduction in heat loss. Instead of fighting against 45-degree surfaces, sucking heat constantly, he was maintaining 60-degree air temperature with 58-degree wall surfaces that barely drew heat. The 6-inch air gap provided approximately R for insulation value 4 times better than bare Earth's R1. The thermal mass stones stored heat with remarkable efficiency that Samuel documented through daily observations. He'd build his evening fire at 6 p.m. using 4 split cottonwood pieces, perhaps 8 pounds of wood total. The fire would burn hot for approximately 90 minutes, then coals for another 30 minutes. During those 2 hours, the interior air would warm from 52 degrees morning temperature after overnight cooling to 65 degrees peak. More importantly, the 3 tons of stone lining would warm from about 54 degrees to 64 degrees to 64 degrees increase. After the fire died around 8 p.m., the cooling process was slow and predictable. By 9 p.m., air temperature would drop to 62 degrees, while stones stayed at 63 degrees, the stones releasing stored heat, preventing rapid air temperature drop. By midnight, air 58 degrees, stones 60 degrees. By 3 a.m., air 55 degrees, stones 57 degrees. By 6 a.m., when he woke, air 52 degrees, stones 54 degrees. The overnight heat released from the stones was providing approximately 8 hours of warming without any fire. The stones were acting as thermal battery, charged by 2 hours of burning, discharged over 8 hours of overnight cooling. His fuel consumption was remarkably low and easily quantified. 4 pieces of split wood per evening fire, perhaps 8 pounds total. At this rate, a standard cord of wood 128 cubic feet, roughly 2 tons would provide approximately 600 fires, burning 1 fire per day. A cord would last 600 days. In practice, accounting for kindling and occasional daytime fires in extreme cold, he estimated 1 cord would last for months, 3 cords for a full winter. Conventional cabins in Lawrence were burning 1 cord monthly, minimum 12 cords per winter. Samuel's double-wall thermal mass dugout was using 1/4 the fuel for equivalent comfort. The controlled airflow system prevented the dampness that plagued conventional dugouts. Fresh air entered through the door gap, flowed across the room, rose at the firebox, warmed by combustion heat, exited through the chimney. The constant slow circulation meant moisture couldn't accumulate. The interior stayed dry despite being mostly underground. December brought the first test of the system. Temperature dropped to 0 degrees for 5 days. Conventional cabins in Lawrence were struggling burning, wood continuously, barely maintaining 55 degrees interior temperature. Samuel's dugout maintained 55 to 60 degrees with his normal evening fires. The double walls and thermal mass were working exactly as designed. But the real test came January 1866 with the blizzard that would prove everything and transform community perception completely. The warning signs began January 13th evening. Temperature dropped from 30 degrees at noon to 20 by 6 p.m. to 10 by midnight, the rapid drop that veteran settlers recognized as Arctic air mass moving in. The wind shifted to northwest, the direction that brought the worst Kansas winter storms. The sky took on a peculiar pale quality that Samuel recognized from military service as preceding major snow. The storm hit January 14th morning with shocking speed and intensity. Temperature plummeted from 10 degrees at dawn to 0 by 9 a.m. to -10 by noon to -20 by 3 p.m. Wind built steadily, 20 miles per hour at dawn, 40 by noon, sustained 55, with gusts to 70 by evening. Snow began around 10 a.m. Not gentle flakes, but dense snow driven horizontally by screaming wind. By noon, visibility had dropped to perhaps 50 yards. By 3 p.m., zero visibility. The world became white chaos where you couldn't distinguish ground from sky, couldn't see your hand at arm's length, couldn't survive exposure for more than minutes. By evening January 14th, the blizzard was in full catastrophic development, temperature -25 degrees and still falling. Wind sustained 60 with gusts measured at 80 miles per hour by the weather station in Lawrence before the anemometer broke. Snow accumulating at 3 to 4 inches hourly. Drifts building to 8 feet in places where wind created eddies. These were conditions that killed livestock caught outside, froze solid, standing up. People caught between buildings died within yards of shelter. The wind chill concept, not yet formalized but understood, practically pushed effective temperature to -50 or colder. Exposed flesh froze in under 2 minutes. Breathing unfiltered air caused immediate lung pain and damage. Samuel's dugout was barely affected by the surface chaos in ways that demonstrated the superiority of underground construction. The structure was 90% underground only. The facing wall with door and oiled cloth window was exposed to weather. The roof was sod-covered, earth part of the hillside, indistinguishable from surrounding terrain. Wind couldn't get underneath the structure to create lift or pressure. There was no underneath. The dugout sat on earth, with earth surrounding it. Snow couldn't accumulate dangerously on the roof. Any snow landing on the grass-covered surface was immediately swept off by 80-mile-per-hour winds or slid off the sloped surface. Inside, the temperature remained stable in ways that would have seemed impossible to anyone assuming underground meant cold. He burned his normal evening fire January 14th from 6 to 8 p.m., same for pieces of wood he burned every evening. The fire heated the interior air to 64 degrees. More critically, it warmed the 3 tons of stone thermal mass from their morning 54 degrees to evening 63 degrees. After the fire died at 8 p.m., the temperature decline was slow and predictable. The double walls prevented the -25 surface temperature from penetrating rapidly. The earthen outer wall would stay around 45 degrees. The ground temperature, at depth, not affected by short-term surface changes. The sod inner wall stayed around 60 degrees, warmed by interior air and separated from the outer wall by the insulating air gap. The stones radiated their stored heat through the night. By midnight, interior 59 degrees. By 3 a.m., 56 degrees. By 6 a.m., January 15th, when he woke, 54 degrees. Cool, but nowhere near the deadly cold above ground. He'd slept comfortably under 2 blankets, while -105 temperatures raged 8 feet above his head. Day 2, January 15th, brought even worse conditions. Temperature hit -30 degrees, with wind still sustained at 60 miles per hour. The mathematical wind chill was approaching -60 temperature that would kill exposed humans in under a minute. The snow continued at 3 inches per hour. Lawrence was buried under 3 feet of snow, with drifts to 12 feet. Samuel's routine was unchanged. He burned his normal evening fire. The thermal mass system continued functioning. Interior temperature cycled between 54 and 64 degrees on the same schedule as every other day. The blizzard happening 8 feet above him might as well have been on another planet, for all it affected his underground shelter. Robert Kincaid's cabin was failing catastrophically in ways that demonstrated the inadequacy of conventional construction under extreme conditions. The frame cabin, 12 by 14 feet, built from milled lumber, conventional design everyone trusted, couldn't handle the combined assault of -30 temperature and 60 mile-per-hour wind penetrating every gap. Cold air was forced through cracks around windows, under the door, through the wall joints where boards didn't fit perfectly. Each gap was perhaps a quarter-inch wide, but the cabin had dozens of them. Under 60 mile-per-hour wind pressure, cold air was being driven into the house continuously. Heat escaped through the thin walls at catastrophic rates. The cabin walls were single-layer boards, perhaps 1 inch thick total, that provided maybe R1 insulation. The interior was 65 degrees when maintained by fires. The exterior was -30. The temperature gradient across 1 inch was 95 degrees. Heat was escaping at unsustainable rates. Kincaid burned wood desperately, fed the stove every 30 minutes, maintained roaring fires continuously, but couldn't keep up with heat loss. By evening January 15th day, the cabin interior was 45 degrees despite burning through 4 days' worth of wood in 2 days. By midnight, 40 degrees. His 3 children, ages 4, 6, and 8, were layered in every piece of clothing they owned, wrapped in every blanket in the house, still shivering. His wife Mary was showing early hypothermia, confusion, slurred speech, difficulty with fine motor tasks. By morning, January 16th day, the situation was critical. Cabin interior 38 degrees, despite having burned every accessible piece of wood. The children, showing dangerous hypothermia symptoms, lethargy, skin grayish-blue, breathing shallow. Mary, barely responsive. Kincaid knew they'd die if they stayed, needed different shelter. Remembered Samuel's dugout half a mile south. The stone-lined hole everyone had mocked, made the desperate decision to attempt the journey despite blizzard conditions that made a half-mile walk potentially fatal. He made the desperate decision to seek shelter at Samuel's dugout, bundled his family in every blanket they owned, fought through waist-deep drifts the half-mile between properties, arrived at the dugout, frost-covered and hypothermic, barely able to knock on the door. Samuel opened the door, and warm air rolled out 58 degrees, meeting -25, creating visible vapor. Kincaid and his family stumbled inside. The contrast was shocking. Kincaid's cabin had been 40 degrees that morning, and dropping Samuel's dugout was 58 degrees and stable. Warmer, underground stone cave, warmer than above-ground wooden cabin. How? Kincaid asked, when he'd warmed enough to speak. "How is this warm?" "It's a hole in the ground, lined with rocks. Rocks are cold. Underground is cold." "How is this warmer than my cabin?" Samuel explained, while tending his normal small fire, the engineering principles he'd learned building military fortifications. The double walls creating insulation, the thermal mass storing and releasing heat, the protected underground location preventing wind exposure. The whole system working together to create stability that conventional construction couldn't match. Your cabin loses heat through thin walls directly to cold outside air. Wind pressure forces cold through every gap. My dugout has earth surrounding it, millions of pounds of thermal mass maintaining ground temperature. The double walls prevent rapid heat transfer. The stones store heat from fires and release it slowly. I'm not fighting against the weather, I'm insulated from it. 5 people crowded into the 16-by-12 dugout for 4 days while the blizzard persisted. Cramped, but survivable. The thermal mass system continued functioning. Samuel's small evening fires heating the stones radiating warmth through each night. Interior temperature stayed between 55 and 62 degrees through the entire storm. When the blizzard ended, January 18th, they emerged to find Kincaid's cabin at 28 degrees inside below freezing, despite being enclosed. His winter wood supply was severely depleted. The storm had killed one of his cattle that was caught outside. The conventional cabin everyone assumed was superior had failed, while the crazy stone-lined hole had maintained better conditions with minimal fuel. Kincaid stood outside the dugout, looking at the grass-covered hillside, with only a door and chimney visible. Understanding that he'd been completely wrong, that the Union veterans' military engineering knowledge had created shelter superior to conventional construction. "I owe you an apology," he said quietly. "I mocked your dugout, called it a tomb, told people you'd freeze in it. Instead, it saved my family's lives when my proper cabin nearly killed us. You were right. I was wrong. I'm sorry." Samuel, who'd seen enough death in the war to not take satisfaction from being right, just nodded. "The principles work. That's what matters. You and your family survived. That's what matters." By February, 9 families in the Lawrence area had visited Samuel's dugout to study the construction. The double wall concept, the thermal mass stones, the controlled airflow, the underground protection. At 25, Samuel became the informal expert on efficient frontier construction. He began consulting, helping families improve existing dugouts or build new ones using his principles. Would explain the physics of thermal mass and insulation. Would show them how to calculate heating needs and fuel consumption. Would teach them that understanding engineering matters more than following tradition. The cost effectiveness was documented through that winter. Samuel's dugout had cost approximately $37. Total materials for door, window covering, chimney pipe, and tools required 1/3 cord monthly fuel. A conventional cabin cost $60+ in materials and required 1 cord monthly fuel. Over a 5-year lifespan, Samuel's dugout saved approximately $100 in construction and fuel costs combined. But the real value was the reliability during extreme conditions. When the January blizzard tested every structure in Kansas, the double-wall thermal mass dugout maintained stable, livable conditions while conventional cabins failed. The engineering knowledge from building military fortifications had translated perfectly to frontier survival. Samuel lived in the dugout for 4 years. Married in 1816 Nina, schoolteacher named Elizabeth, who appreciated his engineering knowledge and understood the practicality of efficient shelter. They eventually built a larger frame house, using money he'd saved from not spending on heating fuel. But they kept the original dugout functional, used it as storm shelter, root cellar, and demonstration of thermal engineering principles. Samuel would bring visiting families to show them how double walls and thermal mass created stability, would explain that frontier survival required understanding physics, not just following tradition. He died in 1914 at age 74. His obituary mentioned his Civil War service with the Corps of Engineers, but focused primarily on the dugout, the double-wall thermal mass design that had saved lives during the blizzard of January 1866 and changed how Kansas settlers understood efficient construction. The dugout site still exists, preserved by the Kansas Historical Society. Archaeological excavation in 1978 revealed the double-wall construction, exactly as Samuel had built it: earthen outer wall, 6-inch air gap, sod block, inner wall, stone lining. Modern thermal analysis confirmed the efficiency. The structure maintained approximately 55 degrees interior temperature with minimal heating, even during extreme cold. The story is about a veteran who brought military engineering knowledge to frontier survival, who proved that understanding thermal mass and insulation matters more than conventional assumptions, who showed that the crazy stone-lined hole everyone mocked was actually superior shelter because physics doesn't care about tradition, because sometimes the person who builds different knows something everyone else doesn't. The dugout that looked like a tomb was actually perfect thermal battery, and military fortification principles applied to civilian shelter saved lives when tradition failed.